right, here in 10.2, we're going to be talking about arithmetic sequences. So 10.1, we kind of got the overview of the sequences, and honestly, 10.1 is probably the more difficult between these two. So I think a lot of what you're going to see in 10.2 here is actually review from things you did all the way back in Algebra 1. So certainly the summation notation we didn't hit in Algebra 1, but a lot of these, first few examples we did. So I'm hoping that you'll find this lesson pretty easy. So a sequence is considered arithmetic if there is a number, which we'll call D, such that a sub n plus 1 is equal to a sub n and then plus that number D. Now, notice the notation here, a sub n plus 1 means the term after a sub n, because second term is after the first term, so on and so forth. D is called the common difference, so that's how we decide if a sequence that we're given is arithmetic or not. If we can find a common difference where every time we're adding that number. Now, just because we have a plus here doesn't mean we're always getting bigger, because remember that if the value of D is negative, that actually becomes a subtraction. We find the value of D by taking a sub n plus 1 and so it can be any term, and then we subtract the term before it. That will give you the correct sign for D. So it does matter the order since we're subtracting. Then below that, I've got the formula for finding the nth term. This is the same one you learned in Algebra 1. Any general term is found by taking the very first term plus the term number we're talking about, minus 1, times that common difference. Then the last formula we're going to be discussing is the formula for finding the sum of the first n terms. So sometimes we can just notate that as sub n. So if I'm finding the sum of the first 10 terms, that would be s sub 10. Or we can also write it as a summation. Here in this formula, they use k, which you can use I if you want. They are saying we're going from k equals 1 to n times the rule, which is a sub k. And then that is finally equal to, and this is the part of the formula that we really use the most when we're finding a sum of the first n terms. You take n over 2 times the sum of the first term and the last term. All right, so let's take a look here at some examples. So example 1 just wants us to write the first 5 terms of the arithmetic sequence if a sub 1, which means the first term, is 6 and the common difference is 2. So this one really doesn't need a lot of work because I think we're all pretty capable of addition and subtraction here. So start with the first term. And remember that this is a sequence here, not a summation, so commas between. If D is negative 2, that means we're going to be subtracting 2 each time. So that would give us 4, then 2, then 0, and then negative 2. So these would be our first 5 terms. So just plug and chug, pretty easy. In example 2, we have it set up a little bit differently. We're trying to find the nth term, in this case the 6th term, if we know that the first term is 13 and the common difference is 4. So here I would use the formula for finding the nth term. So I'm going to write a sub 6, because that's what I'm trying to find, equals a sub 1, which is 13, plus n minus 1, so in this case my n is 6, 6 minus 1, times the common difference, which is 4. So order of operations still applies. Inside the parentheses here first to give us 5, then the multiplication. so that gives us 20. So we have 13 plus 20, which gives us 33. Number 3, example 3, write a formula for the nth term of this given sequence, then use it to find a sub 16. So this is obviously a two-part question. So the first one is writing the formula. So meaning we need to have a sub n equals and then our little formula. So we know that the nth term, so that means that this is in general finding an nth term, not a specific term, equals first term, which is 1, plus n minus 1. So because this is the general term, that just stays n, times the common difference. So the common difference we get by taking a sub n plus 1, so let's use a sub 2, minus the term before it. So n, or not n, d equals 5 minus 1, which is 4. Now you could have also done 9 minus 5, 13 minus 9, but the order is important. We don't want to do 1 minus 5. That would give us a negative, which is not going to give us the right answer. So then we distribute our 4 over here, so that gives us 4n minus 4, and then we have the plus 1. So 4n minus 3 is going to be our simplified rule. So this is the first part of our answer. The rule, the formula for the nth term is 4n minus 3. Then we're going to use that rule to find a sub 16. So we don't need to go back up. This is what this example is trying to point out. We don't need to go back up and do this all over again. We have the rule simplified. So now I can do a sub 16 equals 4 times my n, which is 16, minus 3. And so that just makes it less work than going back to the beginning. So this gives us 64 minus 3, which gives me 61. So the 16th term, if I were to continue that pattern, would be 61. Now, I do want to encourage you, because obviously sometimes the formulas are a little more difficult than this one. So if you would see something on the final exam and you're like, I just can't get the rule, then at least continue the pattern into this number if you can. Obviously, if it's like 200, you're not going to be able to do that. But even though you would lose points because you haven't used the formula to find a sub 16, you would then still be at least able to get partial credit because you did find what a sub 16 was. Okay, last example, we're finding the actual sums. So here I have things written in two different notations. So this summation notation means I start when n is 1 and end when n is 20. So what I like to do on these is write out the actual sequence and then plug it in to get the actual sum. Because again, you could write out all 20 pieces. And if it doesn't say using the formula, then you would still get full credit for that. Now, if this had said use the formula for the sum of the first n terms and you did it another way, you would lose points, but you would still get at least partial credit. So you could write out all 20 if you wanted to. I'm not going to write out all 20, but I am going to write the first few. So if I plug in 1, that gives me 2 minus 4, which is negative 2. If I plug in 2, that gives me 4 minus 4, which is 0. 3 gives me 2, and then I'm just going to do an ellipses. And my last term is when n is 20. So 2 times 20 is 40. Minus 4 gives me 36. So again, you could, because it's finding the sum, actually just, do all of this if you wanted to. But it's going to be faster to use the formula. So scroll back up here to the formula. It's n over 2 times the sum of the first term and the last term. So n, in this case, I'm finding the sum of the first 20 terms. So that means that it's going to be 20 is my n over 2 times the product of the first term, which we said is -2, and the last term, which we said is 36. So this gives me 10 outside here, 34 here, and then I'm able to very quickly get 340. And that's going to be faster than just adding them all together. All right, B, we're given the thing we want to find the sum of in words. So it says the even integers between 21 and 45. Notice, sometimes people don't pay close attention and they're like, oh, first term and last term. No, that's not going to be the case because these are not even. So the first even integer between these values, meaning the first term, is going to be 22. I also know that my last term, which I don't know what a sub it is, but my last term should be 44 because that's the last even integer in that range. Now, I want to figure out here which term number this is. So if you think about between 22 and 44, and we're counting all of them, so we're counting the 22 and the 44, you could count it out, or you could subtract and divide, but we've got 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, and 44, which is 12 total. So that fills in our A sub 12. We need that because what we're trying to find is S sub 12. So S sub 12, we need n, which we just found, over 2 times the product of the, or not product, the sum of the first term and the last term. So this is going to give me 6 times 66, which gives me a total of 396. All right, super short video here. Hopefully that all makes sense. You can go back and rewind if you need to. Homework problems should look pretty similar to what we've done in these examples. So let your teacher know if you have questions.